Hello everyone, and thank you very much for watching my video. This video is about the project presentation of project simulation of MRes General Engineering Masters of Research in General Engineering. Uh, this is actually a PLC based automation. This project is its name is Centralized Control System for Cement Plant. This is actually a cement automation plant that I've divided into three different sections. The first one is FCS01, second one is FCS02, third one is FC03. FCS stands for Field Control Stations. To make a cement, there are three different sections that the material goes through, and then after that it appears as a cement clinker. The first section is limestone crusher, where limestone get crushed and from big and large pieces into small pieces. Second section is raw mill grinding. Raw mill grinding collects small pieces of limestone and different materials added with the impurities and grind it into small, very small powder. And the third section is FC03, which actually automating clean and the cooler system. The clean actually it's burning all the powder material and changing its chemistry, and the cooler is cooling it down and making it small pieces, small balls called clinker. Right, so I've used three different CPUs, and all three FCs are communicating each other to sharing data for sharing the data. Okay, and right, each FCS has its own program. Each FCS has its own programming, like FCs, FBs, DBs. They're communicating. They're different. They're different communication logics. As you can see, like in they're communicating FC01, FC02. For FC02, all the sharing data are coming on FC01, FC1. That is data sharing. All the data being sent and received are coming in this FC. And for the sending data blocks here, I've used this GB read data from remote CPU. This is actually reading data from ID2, and ID2 is FCS01. Same goes for writing the data. There we are. It is writing the data from ID2, from here to ID2. So sending and receiving 20 bytes. I can go up to 400 bytes per one block, but for the simulation I'm doing only 20 bytes in each station. Right, this is the first software that I'm going to use it to. I've used it to design the PLC, to program the PLC. There is one more software that I've used in this project, is WinCC Explorer. Okay, this WinCC Explorer is actually creates a screen that appears, that collects all the data from the PLC and the plant and show it on one screen. Okay, let's just play. Right, this is the main appearance of the screen. Once we run the project, this is how it appears. But before that, let me show you something. These are different screens, like there are multiple screens. All of them are screens, and they're switching one by one when I'm pressing the command and when I'm pressing the button of this screen. How it's turning up, because when I make a project here, you can only you can make a screen which is going to be one. You can't switch it up. It's going to be one screen, but here I've used it. This is the main screen. I start a picture. When I run this project, This is how it appears. I mean, this picture runs. When you open this picture, you can see it's nothing. I just divided into two. I just divided into two screens. The first one is picture window 1, and in picture window 1 I called header 1, and in picture window 2 I left it blank, right? And in header, so this is the header screen. As you can see, there are different buttons here, centralized control system, everything, clocks, yeah, clock there. Okay, so this is just screen 1, and I'm calling this header in picture window 1. Now in this button, I've done the scripting here as a C language scripting. I've done is this one is setting picture name on main screen to picture window 2 FC01. So when I press this button, it will assign a name in main window in main screen to the picture window 2 is FC01. Okay, same goes for FC02 as well. So what is going to happen, that when I press FC01, then FC01 screen will appear in FC's in picture window 2. And here set picture name main.pdl picture window 2 FC02. So what's happening here? Now the picture window 1 FC01 is this one. So this one is FC01, right? Okay, and this is normal tracer screen. But here you can see there is only on picture window 1 I can see only header screen. Picture window 2 is unassigned. There is no name on it, so there I cannot see any screen. Once I press FC01 here, then it will show FC01 screen. Once I press FC02, it will show FC02. 3 trend. Here trend window, I divide the trend window here in two as well, because there are 3 different stations, so I have to get 3 screens, like 3 trend screens for 3 different stations. For FC01 it will show all the analog parameters like trends, pass parameters. I can change the date from here. I mean, whatever the date I want it, I can go up to 3 months on the record, and I can increase the range as well if I go a bigger hard drive. Okay, same goes for FC02. If I press FC02, FC03, they're all 3 different screens, right? Okay, so this one print screen, I don't have any printer, or else if I want the print screen for this parameters, I can print a screen, press print screen, it will appear here. As you can see, the command has worked, but since I don't have any printer on this computer, so it's waiting for the printer to respond, right? Okay, so here all the parameters, as you can see, are black, like dots, blacks, because there is no communication with the PLC everywhere. Look at this here, there is no communication, so I need to download the PLC. So how I'm going to do it, I just open the simulator. This is actually a simulator. Now you can see S7 PLC simulator 1. There is no PLC defined, so it says nothing. Once I download the FC01 on it, PLC goes on run mode again, and now PLC simulator FC01 CPU 416 downloaded. Now for the second FCS, I need to open another PLC. This is actually a PLC. Like you can see, these are the digital inputs, right? These all the are the digital inputs. This PIW, these are the analog inputs. I can change it to QB as well. If I change it to QB, it will turn up as the output. So whatever output PLC is giving, I will see it on here. So that's done. Now for the PLC simulator to that's done. FC02. Now for the third PLC, I need to open another one. Same goes, same process. Now PLC defined. Once download the C03. I think I have to change the thing first. Yep, that's okay. Alright, so all three PLCs are on running straight now. As you can see, there's communication, so all the black dots have gone. There's a proper communication. So what the PLC, whatever the PLCs, what the parameters is in the PLC, I can see on the screen. Okay, so this is the crusher process. Let's start from here. The first one, I got this symbol table on me. This is the second, this is the controller screen that I can give a command and I give a start and stop command from here. There are three different modes, as I told you in the report and the presentation. There are three different modes. I can run the motor in group mode. In the group mode, I just need to press this group start command, and all the motors will start automatically. If I want to run only one motor, okay, so I need to go into the manual mode. Once I press the manual mode, all the buttons will appear. Now I can start any motor single-handedly. Once the ready signal is here, I can give a start command. If I press the start command here, it will not start because there is no ready signal from the electrical department or electrical cabinet. Okay, right. There is one more mode that I was talking about in my presentation, is local mode. So let's say if I want to run this local mode. Local mode is actually a local start from the field. If there is a testing that they want to do, they want to start the motor locally, and they want to communicate to the CCR. What I can do is, once I press this button, so I got no access here. That means there is no risk from here now. There is no operator can give a command from here. Only it can be run from the local button, and local button is in front of the motor. If there something goes wrong, they can stop it from there as well. If I want this motor back into the CCR, then I need to remove this local button and need to get it into the remote. Once I get the remote, I can move back to the group mode. Okay, so for FCS01, here we are. I need conveyor, apparent conveyor ready is I0.2. Okay, so these are actually the inputs that I need to get it from the hardware. Okay, there we are. These are the hardware that I need to get it from. These are the inputs that I need to get it from the cabinet. Now for the main motor ready, it's 0.7. There we are. Once I press that, I can see that this is the relay signal. I've received it from the electrical cabinet. These are actually the hardware inputs that I'm supposed to get it from the electrical cabinet, but because I'm working on a simulator, so I have to do it on the simulator thing. So the PLC is assuming that it's coming from the electrical cabinet. Okay, main motor ready, conveyor belt 1 ready is 1.4. 1.4. Sorry, 1.4 is 1.4. Okay, then 1.4. Belt conveyor 2 ready is 2.1. Belt conveyor 3 ready is 2.6. 3.6. Belt conveyor 3 ready is 3.6, and the stacker belt is 3.3. Now since my whole group is ready, I can see the indications from here. It's like my group is ready. It's ready to start. If I press this button here, okay, if I press this group start, it will start automatically from the opposite direction, because that's how the cement process start for the conveyor belt. If I want to start this, my group is ready. If I press the start command, so yeah, I was talking about the thing that if I start, so to avoid the choking of the material, like if this motor is, this belt is running and this belt stops, obviously it's going to be choking because all the material is coming from there and this motor is not running. So I have to start the motors from the opposite direction, and I have to close the motor from this direction. Okay. Right. Okay, so let's just start it. But press the group start. The first motor is started. Now I need to give the state signal. This is the signal that I need, that's this PLC is expecting from the electrical cabinet. Once I give into that, it will wait for another 5 seconds and it will start this belt. That's done. Now I need to give this state signal, which is actually a conveyor belt 3. Conveyor belt 3 state is 2.7. Once I've done that, it will wait 5 seconds and it will start another motor. That's done. Now I need to get this electrical state is 2.2. There we go. Once I've done that, wait for 5 seconds, it starts this motor. That's done as well. Okay, belt conveyor 2 state is 2.2, 1.5. Once I've done that, then it will start main motor. Once it's done, I need to give a state signal of the running state signal of the motor, so that it's going to start the 1.0 is there. It's going to start this apron conveyor. Now my whole group is running. Let's just give it the thing. Now because my whole group is running, I can see the group running. My whole group is running. Okay. This is the first step to the thing. Now the second part is reclaimer and the feeding belt. This is actually where the communication starts. They are near to the field control station 1 FC01, but it should be run by the operator of FC02 from here. So what I've done here is I've taken a control from FC01 to FC02, and I can give a command from here, feeding belt and the reclaimer. Okay, let's just start this reclaimer and the feeding belt. Now since it's starting from FC01 but it's getting a command from FC02, so I've done a communication and the control signals are still in FC01. So reclaimer ready is 4.6. Reclaimer ready is 4.6. Once I've done that, there we are, reclaimer ready. And hopper feeding belt 4.3. There we are. And feeding belt. To start the reclaimer, this feeding belt should be running. Let's say if I want to run this feeding belt, reclaimer, this one FC01 here, if I want to run this reclaimer, this belt should be running, or else this motor won't start. Let's check it. If I start this button, it won't start. Okay, reclaimer, this is the reclaimer indication here, and this one is FC01. This is the condition that it should be fulfilled to start the reclaimer. Reclaimer is actually retrieving the material from the reclaimer side, from there the piled up material collected, and send it to the hoppers here. Okay, now to run this motor, I need to start this feeding belt first. Once I start this feeding belt, this motor is started there. I need to give a state signal for this feeding belt. Now the feeding belt, hopper feeding belt state signal is 4.4. There we are. Once I've done that, I can see it's green there and it started from there as well. Now if I want to start the reclaimer, I can start the reclaimer now. Once I've done that, it got green there, reclaimer, I need to give a control signal, like running a state signal for the reclaimer. Here we are, the reclaimer state is 4.7. There we go. Now I can see it here, the reclaimer is running, now feeding belt is running, the material, the limestone, like the crushed limestone, is getting filled in these hoppers now. My first process has been done. I mean, my first section of the process has been done. All the limestones, the bigger limestones, the big curies is coming to this. It's getting here, getting crushed, getting into these belts and getting stored in this 90-meter reclaimer, a stacker reclaimer. Okay, second part is the limestone raw mill grinding. For the second SC02, now I have to open the SC02 screen. It's a PLC, and for the SC02 I got second symbol table on me. Now the symbol table is SC02. The first part is rotor feeder 1 A01. Here I've used different groups like feeding belt group, the feeding belt group, feeding group. The feeding group is raw mill feeding. Raw mill feeding group is this bit. This is the group 1. Okay, there we are. There is second group, extraction group. The material extraction group is this one. This is the group that is getting started in second group. The NFC01 there was only one group. There was no second control screens. There was only one screen. It was running from there. But this FC02, it should be two different screens. There are two different controls. The third one is the VRA main motor. Is not included in any group. It's supposed to start manually. Okay. It's supposed to start automatically. Like, how did I get this? And now the second interesting thing is for these there are 4 wave feeders. 1, 2, 3, 4. First one is for the limestone, and 3 more different materials that needed to use in the chemistry for the cement. And for all 4 materials there is a percentage that chemistry department tells the operator that you need to put this quantity on the wave feeders. So here I did that. Like, once you press this, it will show on the screen. This is the percentages. Let's say if I did 70%, I want limestone. Okay, 70% I want limestone. 18% I want this. Okay, and I want 6% of this and 6% of this. So here we are, 100% of this. And now whatever I will set the wave set point here, let's say I want 180 ton. Now you can see all the set points has already been given with respect to these percentages. If I press this 200, it will change the set point there. Now look at this, the 200%, the 70% of this, 18%, 6% and 6%. And I can hide this. Once I've done that, I don't need to change anything here. I just need to press the set point here. Let's say 150. It will change its set point respectively. Once it's changed the set point, the actual wave feeders will change the speeds with respect to these set points. Now, if we start this FC02, yep, that's it. For the SC02, let's say feeder 1. .0. Okay, welcome to is 0.5. Okay, well, easier 1.2. There we go. 1.2. 1.7. 1.7, 2.4. All the IOs that I'm putting in, I got IO list. I'm watching the IO list because there's a multiple, there's a list of IOs that I've used in the PLC for the software. So I need to have a list to see what the IOs are. Bell converter refeeder 1 is 3.1. So we have 3.1. 3.1 refeeder 2 will be 3.6. 3.6. Then 4.3. So we have 4.3. 4.3, and then refeeder 4 is 5.0. Once my whole group is ready, the group ready indication will appear here, and that means I'm ready to start my group, which is same. I've done the same technology, save logic here, that if I press this auto, then means I can start any motor locally. Let's say I want to start this rotor feeder, or let's say this bucket elevator. Which one is that? This is the reject elevator. If I want to press it locally, I can start it from there. Start. It will appear here. I can stop it from there as well. Done. Stop. Okay. But if I want to start it as locally, then once I done that, I cannot do anything. I got no buttons. I got no controls from here. If I want to control, I need to get it back here and put it back on group mode and start it from there. Once I done that, rotor feeder has started. Now the rotor feeder state is 0.1. Done. Second is belt conveyor 2. Belt conveyor 2 state is 0.6. It will wait for 30 seconds. Every motor will wait for 30 seconds, and within 30 seconds this state signal should come. Now the reject elevator started. It will wait for 30 seconds. If it doesn't appear, it will trip up. Let's wait for it. Okay. If I don't give the state signal to the reject elevator, it will trip the motor. That means electrical cabinet is not responding. PLC is given the command, but it's not responding. So it will, because once the electrical cabinet, look at this strip. Once the electrical cabinet responded and start the motor, it will give a state signal. Once it doesn't get the state signal, the group command will stop wherever it is, like is there. Wanna start it again, reset it, and group start. Once I group start, it will start from there. Now this time I'm gonna give a control signal there, which is reject elevator DE01 state is 1.3. Once done, it will wait for 5 seconds. It will start second motor, which is this one and that one. Belt conveyor 1 and belt conveyor 3. So belt conveyor 3 is started. Belt conveyor 3 is 2.0. Done. Once done, belt conveyor 1 is started. Belt conveyor 1 is 2.5. Now it will start all the view feeders there. Since they got the set points, once they started, then obviously they're gonna give some PV like value. Now they started all the view feeders because it's no point I can start all the view feeders all together, so I need to give them all the view feeders state signal all together. So first one is 3.2, 3.7, 1.0, and 4.4. These are the 4 signals that I need to give it to him. Now my first group, which is this, is group running. My whole group is running. That means raw meal feeding group is running. Now the second group I need to start is the extraction group. And for the extraction group, I need to give some control signals to them, which is this one there. Now the control signals for the way figure group 2 is 6.2, which is this one. Ready, your slide ready. Baghouse 6.7, 6.7. There we are. Ready. And the third one is baghouse fan 7.4. 7.4. There we go. Again, my group is ready here. Now, after giving all the input, I can see my group 2 is ready as well, which means I can give a group start command from there again. Once I group start it, it will start it from A slide, which is A slide input is 6.3. Second input is baghouse itself, baghouse purging. Once it's done, the baghouse purging state is 7.0. There we are. And the next one is gonna be the baghouse fan. There we are. The baghouse fan output is 7.5. Now my raw mill, the complete raw mill is running. All the materials coming from here getting collected here, there, grinded. All the reject materials coming on this belt, reject elevator, putting it back on this belt and going again into the mill. And all the grinded materials coming out of this getting collected in the baghouse. All the fine materials dropping on this air slide and going into the silo, and all the dust is, very thin dust is going into the chimney and into the atmosphere. Now this is the third one. Again, it goes two different groups. The first one is this one, which is clean feeding group is there. Second group is the cooling group. There we go. I've got two more different screens, like clean drive, it's going to run automatically. This one, ID fan. Now for this ID fan, there is a requirement to run this ID fan. For this ID fan, this fan on FC02, this baghouse fan, it should run, or else it will. This is the ID fan, actually it's showing it there as well. Once I start it here, it will show on the screen that this fan is running. To start this fan should be running, or else this fan won't start. So for that, I've done the communication again. I'm sending this running state to the FC03. Once this FC03 block get this running state, then this motor will start. Okay. Right, for the group 2, group 1 here, for the FC03, here we go, symbol to there for the FC03. Ready is 0.0. 0.0. Air slide ready 0.5. Refeeder ready is 1.2. Once I've done that, my group is ready. Reset, group start. My elevator is started. Now the elevator state is 0.1. Yep. Second is air slide state is 0.6. There we go. And the wave feeder state is 1.3. There we go. Now for the diverter, this is the diverter that diverts the feed. Either this feed goes into the preheater. This is the preheater section. as the material goes into the preheater or goes into the back to the silo. This is actually a silo direction. Okay, so now my group 1 is running. Let's give you this diameter indication as well so that can. There is 9.0. There we are. This is the indication. Now all the material coming out of the silo through wave feeder. This is slide elevator going to on top of the feeder and going back into the silo. This is the circulation. Now I'm circulating the feed. Now the second step is this one. This is the second group. This is actually a cooling group, and for that I need to fan 1 ready 3.0. Okay, so 3.0. There we are. Let's give them all the input first, and then with group fan 2 is 3.5, 3.5, fan 3 is 4.2, fan 3 is 4.5, fan 4 is 4.7. As you can see, I've got 4 motors as ready. Then fan 5 is 5.4, fan 5, fan crusher 1 is 6.1, crusher 2 is 6.6, crusher 3 is 7.3, fan conveyor is 8.0. Now my whole group is ready. Now this cooler drive is not part of the group, so that's why if I ready it after, it's gonna run. So let's start this group 2. Group will start. Once I've done that, it will start pan conveyor. There we go, pan conveyor there. Pan conveyor state is 8.1. It's gonna wait for 30 seconds. If I don't get it, it will trip. Once it get it will wait for 5 seconds. It will start crusher 1. So for the crusher 1, we got a state as crusher 1 state is 6.2, which is this one. It is gonna wait 5 seconds, then it will start second crusher. There we go. Crusher 2 state is 6.7, which is 6.7 is this one. It's gonna wait another 5 seconds. We start crusher 3, which is 7.4. There we go, 7.4. It will start fans now. There we go. Now the fan 1 state is fan 1 state is 3.1. There we go, 3.1. Second one is going to be 3.6. There we go, 3.6. 4.3. Next is 4.3. There we go. 4.3. Then 5.1. 4.3 and 10. 4.7. No, 4.7, 5.0. There we go, 5.0. Last but not the least is done. There we have 5.5. 5.5 state is 5.5. Yep. As I can see that my group 2 is running as well with group running indication. Now for the cooler drive, I can start it. Now the cooler drive ready is 8.5. Now for the 8.5, here we are. Once I've done that, it will show me that this is ready. I can start it by pressing the start button. Once I've done that, the cooler is started, as you can see. Right, now I need to give it a series signal, or else it will trip in 30 seconds. Now the cooler drive is stated 8.6. There we are. Now I need to start this burner. This is the burner which actually burns the fire into the clint. Now the burner state is burner ready signal is where is the burner? Yep, 2.5. There we go. Started. Yep. For the burner, there is a requirement that I need to fulfill, which is I need to start this ID fan first. Now the ID fan ready is 2.2. 2.2, which is that. Did I press the right button? No, it's not. That's a clean drive ready actually, sorry. ID fan ready is 1.7. .7 is this one. There we go. Start. ID fan started. 2.0. Now the 2.0 is this one. There we go. Now the plant is running. Cooler is ID fan is running. I can start this. Now the burner is started. Now the burner state is 2.6, which is this one. Now the last step that I need to start is a clean drive, and the clean drive ready is 2.2. Without starting a clean drive, I cannot take the feed. Like if I want to take a feed of forward on, it won't take it. So all the conditions should be fulfilled, then it will take the feed, or else it won't take it. Right? Okay, let's start it. Clean drive is 2.2, which is this one. There we are. That's ready. Step command and start. There we are. Clean drive started. My clean drive state is 2.3. There we go. Now since my whole plant is running, I can give it on command. It will take the feed from here to there. Now I need to give a state signal, which is 9.1 for the diverter. There we go. Now my whole plant is running, and I can see all the things. If anything goes wrong, if anything trips, let's say if I trip this ID fan, or let's say if I trip this baghouse fan, for this baghouse fan, once it's tripped, then it will trip the purging, it will trip this A slide, and it will trip this ID fan as well, because this is the condition that should be fulfilled. Even though this is running from FC02, but it will do the tripping on FC03. Once it's tripped, it will divert the feed and it will stop the burning as well. Okay, let's do this. Now for the FC02, we got baghouse fan state, baghouse fan state is 7.5, which is this one. Let's go on screen 3, and I'm dropping the state on FC02, which is 7.5. If I drop this input, look at this. Once done, I define trip, feed divert, burner trip, and on FC01, this fan trip as well. And if I want to start it again, I can start it, press this grip 2, reset, but grip start again. It will start this motor. Now the fan speed is 7.5. Once it's done, I can start that ID fan from here, which is, I need to remove this ID fan state first. Since the ID fan state is running, it won't take the command, so I need to remove this ID fan state. No, FC03. ID fan state is 2.0. 2.0. There we go. Start and started. Let's get back the signal to this. Done. Now I want to start this burner. Now for the burner, I need to remove this burner signal as well, which is 2.6. 2.6. Stop. Start. Once I'm done, let's give back this 2.6 signal back here, and my whole group is running. Let's take the feedback again. Hold on. There we go, and the system is starting again. Now since this baghouse fan trip, I can check it, the alarm. We are in baghouse fan trip on state signal missed alarm, because I removed the state signal, so we got the alarm there. It tripped on 194906. And if I change the parameters here, let's say these are analog parameters, which I can change it, I can see all the alarms in SC01, in SC02. There we go. These are the parameters. I can change this to there. I can change the time. Since there's no, this is a simulator, so it's going as 0 parameters, because I'm not changing any parameters in the PLC. In the simulator, if this is an actual PLC, there might be different parameters, different lines. Thank you for watching my video. Thank you very much. Bye.